So we have learned a ton of methods for integrating functions, and here in section 7.5 we're just going to review everything. So if you, on the exam, I'm going to give you a whole bunch of problems to integrate. So integrate this, integrate this, integrate this. So what should your strategy be? Well, number one, you, if it's not obvious right off the bat, you want to simplify your integrand, the function you're integrating, or sometimes change its form. Number two, try the easiest method first. Try a U substitution. See if you can do that first before doing like integration by parts or trig substitutions or something like that. Step number three, if it's not an easy U sub, then classify your integrand. So if it's a polynomial with e to the x, a trig function, or a log function, that's telling you integration by parts. If it's a rational function, polynomial divided by polynomial, that's partial fractions. If it's products of sines and cosines or tangents and secants, then trig integral, so that's a U substitution. If it's got x squared plus or minus a squared, or vice versa, that's going to be a trig substitution under the square root. And if it's got square root without the squares, that's a rationalizing U substitution. And then you may have to use more than one method. So you may have to go back and use more than one. So let's look at a whole bunch of examples here. So let's start with an exponential integral. We want to integrate 3 to the 2x plus 3 to the x dx. So, well, remember that the derivative of 3 to the x is 3 to the x, and then times ln 3 log of the base. So I think I might try and rearrange this and see if I can get another 3 to the x in there, because I see it in the exponent here, and that's in part of the exponent over 3 to a power. So, well, when you multiply, you add exponents. So I'm going to do that backwards. So this is equal to the integral of 3 to the 2x times 3 to the 3 to the x dx. And then when you multiply exponents, 2 times x, that came from a power to a power. So this is the integral of 3 to the x quantity squared times 3 to the, that should be an exponent there, 3 to the x, 3 to the x dx. So now I look at this and I say, aha, here I got a function and its derivative up to a constant. So I think I'm going to try and use a U substitution here. So let's try U is equal to 3 to the x, and then du will be 3 to the x ln 3 dx. So let's see here. So this will be 3 to the u. One of those 3 to the x's is going to go with my dx to make my du. So I'm going to write this as 3 to the x times 3 to the power 3 to the x, and then times the other 3 to the x dx. So here's my du almost. I need a factor of log 3 in there. So I'll go ahead and multiply by ln 3 here and divide on the outside to compensate. So now I do have my du. So this will be 1 over ln of 3, integral of u, and then 3 to the u du. So there we go. So that definitely simplified that integral. And now I look at this and I'm like, oh, I got a power times an exponential here. So if you got a polynomial or a power times an exponential, that's going to be integration by parts. So we want to pick a u and a dv here. So I want to pick u equals and dv, and then our du and v. And since we're using u over here, why don't we change this u to a w? So that'd be w, w, w. There we go. So you want your u to be the part with a simpler derivative, so that's going to be w. So du will be dw. My dv will be the 3 to the w dw. And remember, when you integrate 3 to a power, you get 3 to the power, and then divide by log of the base, ln 3. So now in the next step, this will be, got that 1 over ln 3 out in front, and then you want uv, the diagonal product, minus the integral of the bottom. So w, 3 to the w over ln 3, minus integral v du, just 3 to the w over ln 3 dw. And then this 1 over ln 3, we can pull that out in front, and the integral of 3 to the w is 3 to the w divided by ln 3. So you got a 1 over ln 3 here, w 3 to the w over ln 3 minus 1 over ln 3, and then integral of 3 to the w is 3 to the w divided by ln 3. And now we've done all our integrating, plus c. Now we've got several log 3's that are floating around in here. We could clean that up a little bit. We got a 1 over ln 3 here and a 1 over ln 3 common there that we could bring out in front with this 1 over ln 3. So it'd be 1 over ln of 3 squared. And then what's left will be the w 3 to the w, and then minus this ln 3, 1 over ln 3 is factored out, 3 to the w over ln 3. And plus constant. And then notice, I guess we got a common 3 to the w that we could pull out if we wanted to. But we'll go ahead and leave this. So 1 over ln of 3, quantity squared, and we just need to reverse our substitution. Our w is 3 to the x, so this will be times w there, 3 to the x, and here 3 to the 3 to the x power minus 3 to the w, so that's 3 to the 3 to the x, divide by ln 3, and then plus our constant, and we got it. So two methods here. We did a u substitution plus integration by parts.